Another way of stating this problem is we're looking for all integers n such that n cubed minus 3 over n minus 3 is a proud member of Z. It's all in the set of integers. Okay. This divides operator means the very same thing as this, or you could just say that n cubed, this is good enough. This and this are equivalent, okay? Now, the way the guy that wrote this problem solved it was just using straightforward vertical divides bar logic. I chose to do synthetic or long division. Now, this is what happens when you do long division. You get this quotient plus another quotient. In other words, this is the quotient of the division. Then you get this quotient 24 over n minus 3, where 24 is the remainder and n minus 3 is the divisor here. Now, let's see if I can show you. The synthetic division isn't too hard. Let's see if I can remember how to set that up. I think you end up with something like this. Okay, so let's just write down these coefficients. Now there's a 1 here, but there's a couple of zeros, so you have 1. Now there's not a squared term, so you write a 0 in there, because you could think of this as 0 n squared. There's not a linear term, so you can put another 0. Then you have minus 3 like that. Okay, now the idea here is, is to take this 3, place it right here. Okay, and I may run out of room here. You bring this 1 down. Okay, so you get 3 times 1 is 3. Okay, right here, I guess I'm not writing this exactly right, but so you have a 3 here. Now 3 times 3 is 9. You have a 9 there. And so then you bring that 9 down. And then you write 3 times 9 is 27. And you end up with 24. Okay? And you can see exactly where everything comes from. You see this 3. This 1 that you see right here would be the 1 here, the coefficient of n squared. This 3 is the coefficient of the linear term. N is the constant term. Right here. And then, 9 is the constant term. And then you have this remainder, which is written over the divisor. This 24 is this 24 you see right here. Okay? Now, the reason why this is useful, and again, the way the guy that wrote this problem did it was just use vertical divides bar logic all the way through it, but this seems to be the easier way in my opinion. Okay, because we know that this piece right here, if n is an integer, then this circled piece is necessarily an integer, right? But you see, this piece right here is only an integer if n minus 3 is equal to one of the, 16 divisors, okay? You have 8 positive divisors of 24 and 8 negative divisors of 24. So there's 16 total divisors. So n minus 3 has to equal to all 16 of those divisors in order for this piece right here to resolve to an integer, okay? So all you really have to do here, and this part is just tedious, you're going to set n minus 3 equal to each of the 16 divisors. And so that's the same thing as adding 3 to all of these divisors. So y'all, I'm gonna just write it out. 3 plus 1 is 4. And that's very clear, right? 4 minus 3 is 1, so obviously you could do that by inspection. Now, the rest of them, though, aren't quite as clear, so we're going to add 3 to 2, and you get 5. Add 3 to 3, and you get 6. Add 3 to 4, and you get 7. So far, we're just counting here. Add 3 to 6, and you get 9. Add 3 to 8, you get 11. 3 to 12, you get 15. Okay, and then add 3 to 24, and you get 27, right? And again, you can just check. If you put a 27 right here, you just get 24 over 24, which is 1. If you put 15 right there, you get 24 over 3. So it's, so it's not very hard. And then now you're going to add 3 to the minus version. So 3 plus -1 is 3 plus -1 is 2. 3 plus -2 is 1. Okay. 3 plus -3 is 0. Zero's included here. And, that's easy to see. 0 minus 3 would give you -8 right here. Okay. Now we need to add 3 to -4. That's where we start getting some negatives. Again, I added 3 to -4. 3 to -6 is -3. Okay. 3 to -8 is -5. Add 3 to -12. What do you get? -9. And finally, 3 to -24, and you get -21. Right? And y'all, again, you can check these out. If you put -21 right here, you would get -24 down here, so that would be -1. -9 would give you -12. -5 would give you -8, which is the divisor of 24, and so on. So if I have made any mistakes, these are the answers. There should be 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the answer. And again, y'all, this is, I think, the standard way to do it in any kind of math competition, even though this isn't a particularly challenging problem. But again, number 2 in Sierpinski's 250 number theory problems didn't use this division algorithm to solve this problem. He just did a lot of logic and reasoning with this vertical bar divides operator. So anyway, again, these are the 16 answers.